There we go. Now I'm recording. Okay, so we, as a class, all of us have done A through F. Reminder, I taught us about the transformation. So I taught us, we did, if there's a transformation out front, if there's a change in your A value, that amplitude. Similarly with B, if you have a number being multiplied in front of it, that's the same thing as 2 pi divided by B, that's your new period. And then the very last in class was C, anything on the inside, X minus C, X plus C, that moves something left and right. And then the D moves it up and down. We've done this in other units with other functions, but we haven't done up and down movements yet. So we're gonna do 1 or 2 more just left and right movements, but know that the up and down is coming. And this is exactly what we think. Up is a positive thing being added. Down is if you have something being subtracted or minused off. Okay, so we're just reminded all those. You have all of these other examples. For anyone who missed the 4.4 lesson, it didn't save when I was trying to record it yesterday. I'll record it later today and add that online too. So let's jump to letter G. I think I want to do letter G and I. We'll skip letter H for now. So here I'm going to look at what I have. So I have 1/5, 1/2, and this plus pi over 8. Okay, 1/5 is my A. And so that's going to affect my, oh, poor Curtis can't get in. A equals 1/5. So my amplitude is not 1 and -1. It's now kind of crunched into 1/5 and -1/5. My period is not just 2 pi, it's going to be 2 pi divided by 1/2. So 2 pi divided by 1/2. As we've been doing dividing by fractions, that's the same thing as 2 pi times the reciprocal, which is 2. So my period here is actually going to be 4 pi. That's a little bit extended from what we normally have. So normally we have to get our sine or our cosine within 2 pi units. Now I'm kind of doubling it. So it's going to be like long and stretched out a little bit. And then this plus pi over 8 means that I'm going to move to the left pi over 8 units. So instead of starting at 0, I'm going to negative pi over 8. Okay, so now let's set our graph up. So I like to get our little grid marks up. So I've got 1/5 and -1/5. That's pretty easy. So I'm going to add that first. And you can put those marks wherever you want them, as high or as low as you want them. And then I have to start at left pi over 8. So I'm going to put a mark in here for pi over 8 already. Negative pi over 8. That is my like left bound of my grid. And I have my top bound and I have my bottom bound. Okay, that one's a little crooked, that's okay. And they can go as far as I want. I can make my line wherever I want. I'm just going to make it here. Again, you could go all the way to the arrow. You can stop at whatever point, but you have to just decide this is where we're going to end. This is probably the hardest part for us, is this is not 4 pi. This is going to be together with this pi over 8. This all is 4 pi. Instead of starting at 0 and ending at 4 pi, I'm shifting everything over pi over 8. So instead of ending at 4 pi, this point right here is essentially 4 pi minus pi over 8. We're just moving to the left pi over 8. I think this is the easiest way of thinking about what this point is. 4 pi is the same thing as 32 pi over 8, because we know 32 divided by 8 is 4. And then I'm going to minus pi over 8. That when I minus that out, 32 pi minus 1 pi is 31 pi over 8. And you don't have to write this out because I'm going to do a lot of these little calculations off to the side. But this last point, this is now 31 pi over 8. And again, I got that by doing 4 pi minus pi over 8. I'm going to find all the other points by finding that pi minus pi over 8 as well. So if this was a normal graph, and I'll do this in a different color just so you can kind of see what I'm talking about. If this was starting at 0, 0, I would have ended at 4 pi. My middle point would have been at 2 pi. Don't write what I'm writing. My other, like my second point would be at pi, and then my like third in between point would be at 3 pi. I know this is not to scale, just pretend with me. All of my numbers are going to be moving left pi over 8, left pi over 8, left pi over 8. So just like I did 4 pi minus pi over 8, I'm going to do 3 pi minus pi over 8. And I'm going to do 2 pi minus pi over 8. And I'm going to do 1 pi minus pi over 8. And that's going to give me all of these points. They're not going to be necessarily right here. I need to erase it. They may not necessarily be right where I had them before, but they're going to be kind of evenly distributed here. And again, this doesn't have to be super to scale as long as we have the points labeled. So that middle point is 2 pi minus pi over 8. So 32, oh no, that's not 32. 2 pi over 8 is 16 pi over 8. So 16 minus 1 is 15. So this middle point is 15 pi over 8. The second point is pi minus pi over 8. Well, pi is like 8 pi over 8. So if I minus 1, 8 minus 1 is 7 pi over 8. And then that third point would be 3 pi minus pi over 8. And I've got all the scribbles off to the side. I don't need that anymore. I don't need that. 3 pi is the same thing as 24 pi over 8. So 24 pi over 8 minus pi over 8 is 23 pi over 8. So I took all of these. I took essentially 4 and minus an 8, 3 minus an 8, 2 minus an 8, 1 minus an 8. And the reason I wanted to do that is because I need my 5 points. I need a beginning, I need a middle, I need an end, and I need the 2 in between the middle and the first, and the middle and the last. Now that I've gotten to this point, now that I have my graph all labeled and I have my grid all done, I'm going to graph cosine. So cosine, we remember, if you don't remember, we scroll back up to the top. It's going to start and end high. Its middle point's the lowest point, and then it's 2 in between at like the middle line. Our middle line here, since we haven't moved up and down at all, is still at 0. So I start at the highest point and I end at the highest point. My middle point's the lowest, and then my other 2 are at 0. So I connect them all like that. I do think the hardest part is finding the labels to those. So we're going to do a couple more examples to hopefully kind of get that kind of stuck in our head. Does anybody have any questions yet?
Nope.
Awesome. Thank you. Let's move down to the letter I. We'll skip letter 7 for now. I think the 1/7 fractions are a little crazy. So we'll go down. We'll do a 1/6 fraction. Okay, so we find all of our pieces. I've got 2/3 is my A, so that means my amplitude is 2/3. I have 2/3 is my B, so that means I'm going to do my 2 pi divided by 2/3. Write that down. So my period, I'm going to do 2 pi divided by 2/3. So when I multiply that by the reciprocal, I get 2 pi times 3 over 2. And the 2's cancel. So my period now is 3 pi. So within 3 pi's, I need to get my whole sine or cosine down. This time it's cosine again. And then this plus pi over 8. Again, we haven't done any up or down transformations. This is our third left and right transformation. We did one in class the other day. We're doing one now. And this one's going to go left pi over 6. Left pi over 6. Okay, so now I set my little pitter patter up. I set my screen up. I'm going left pi over 6. So I'm going to go over here to negative pi over 6. And then you can end wherever I want, but this whole distance is going to be 3 pi. If I had started at 0 and gone 3 pi, then I would have ended physically at 3 pi. But I've started left pi over 6. So that means just like we did on the last problem, I'm not going to be at 3 pi. I'm going to be at 3 pi minus pi over 6. 3 pi minus pi over 6. 3 pi is the same thing as 18 pi over 6. So 18 minus 1 is going to be 17 pi over 6. Let's start our little amplitudes up while we're thinking about it. 2 over 3 and then negative 2 over 3. You can put those wherever you want on your graph as long as they're labeled. No, that's fine. Okay, I'm drawing my little barrier so I can keep my whole graph inside that little box. Okay, now I'm looking for my halfway point. Half of 3 pi, half of that is 3 pi over 2. So if I was at a normal, if I had ended at a normal 3 pi instead of at 17 pi over 6, my middle point would be 3 pi over 2. But I'm not ending there. I have to go left pi over 6 from there. Pi over 6 minus 3 pi over 2. This is where our big fraction work comes in. So I need like denominators. Let's multiply by 3 on top and bottom. This gives me 9 pi over 6. And 9 pi over 6 minus pi over 6 is going to be 8 pi over 6. Oh, and I can actually simplify that a little bit more. That becomes 4 pi over 3. So this middle point is 4 pi over 3. Okay. Again, a lot of this is fraction work. I told this to you in class. The hardest thing is going to be this. If you really struggle with fractions, maybe we need to do some office hours to get that all figured out. Okay, now I'm going halfway between where I was. So if this was my normal graph, if I was at 0 and 3 pi and my middle point was 3 pi over 2, halfway between 0 and 3 pi over 2 would be 3 pi over 4. So in order to figure out my new point, it's not just 3 pi over 4, it's 3 pi over 4 minus pi over 6 like we've been doing this whole time. So 3 pi over 4 minus pi over 6. All right, now I need to do a lot to get like denominators. We got to get, I think 12 is the easiest thing. So I can multiply by 2 on the second fraction, 3 on the first. I get 9 pi over 12 minus 2 pi over 12, which is 7 pi over 12. Okay, the only nice part about that is I don't have to simplify it. It's kind of an ugly number, 7 pi over 12. Okay, the last little bit of fraction work in order to find that very, very last point, and then we can just draw our cosine and move on with our lives, is I have to go one more jump over. In order to go from 3 pi over 2 to 3 pi over 4, you had to minus 3 pi over 4. Essentially, the 3 pi over 4 is the same jump everywhere. So I'm going to think of adding 3 pi over 4 plus 3 pi over 2 to figure out what this in-between one is. This fourth point is always the hardest one. So again, like denominators, multiply by 2. That gives me 6 pi over 4 plus 3 pi over 4. It's going to be 9 pi over 4. And again, I don't get to use that one. I have to do that minus pi over 6 because we have to move everything left pi over 6. Well, I picked a tough one for our brains this morning. Okay, let's multiply. Let's get 12 on our denominator again. So that's 2 pi over 12. And this is 27 pi over 12. So when I minus, I get 25 pi over 12. All right, that was some tough work. Again, fractions are messy. We may need to think about that. You may need to do some like just individual fraction work. If the pies bother you, just do these fractions without pies. Think about if I'm going from an interval of like 0 to 3, like what's in the middle between 0 and 3, what's a quarter of the way in, and what's 3/4 of the way in. So you can think of this, if you drop the pi, that might help you too. So just a little hint. I'm going to draw cosine. We remember cosine starts and ends high, its middle point's the lowest, and its two other points are at 0. So once I have this box, the physically drawing it is the easiest part. I had to teach us the shape so we knew how to use it, but the physically drawing it's the easiest part. Okay. All right, and I'm going to erase all these messy fractions just for the sake of my paper. Okay, any questions right now?
So we're just like, if it doesn't have anything with like the C or the D, like our points are like pi over 2, pi, 3 pi over 2, and 2 pi, and we're just changing them like, okay.
Yes. So what I'm thinking about is I'm like, okay, I have 3 pi as my period, which means that if I didn't have this, if I didn't have to move left pi over 6, I would just go from 0 to 3 pi. And so again, teachers might teach this differently, and each one of you might have kind of a little different trick, but like, I think the easiest thing is like, okay, what would these points be? And I'd said, okay, 0, 3 pi, 3 pi over 2, and then I forget what those other two were. And then I'm like, okay, what if I shifted them all left pi over 6? So I'm figuring out what the original points are and then minusing pi over 6 each time to show that they're going left pi over 6.
Okay, thank you.
You're welcome. Good question. Okay. Anybody else? Oh, got a new friend. Okay, I'm going to jump down to number 2, and we're going to do just letter A for today. If I have time, I can come back and do letter B, but we'll just do letter A. I could spend a whole month on graphing sine and cosine, so I'm just trying to do like the most important stuff, I think. So I'm on number 2, we're still in 4.4, and it says write a sine and a cosine equation for this graph. So we're going to write an equation that has sine in it and some other pieces, and we're going to write an equation that has cosine in it and some other pieces. So first thing I'm going to do is I'm going to do sine. So we know that sine starts at 0, 0, and then it goes up and it loops all the way down. So I physically see a sine graph right here. I think that's the easiest thing to see. So that's what I'm going to start with. In our normal sine graph, our amplitude is always 1. In our normal sine graph, if you go all the way up to the top of the page, which I'm not going to do just so you don't get dizzy, the very top of the page, amplitude is always 1, period is always pi over or 2 pi. So what I'm doing is I'm saying, are there any changes to that? And did I move left and right any or up and down any? What I notice is that it goes as high as 1/5 and it goes as low as -1/5. So that's adjusting its height, its vertical stretch and shrink. That's its amplitude. So that means out front, my A becomes 1/5, 1/5. I also know that it doesn't start at 0. Its first point is at pi over 6. So that means I moved left and right. In this case, I moved right. So I'm going to do x minus the starting point, pi over 6. And then this is again what we always struggle with because it's kind of the fraction part. It's the period. It's like, how long did it take to do my whole cycle? It looks like I did my whole cycle from pi over 6 to 5 pi over 6. So let's see what that actual distance is. To find that actual distance, I'm going to take the last number and minus the first number. So that's going to tell me like the actual length it took. So if I do 5 pi over 6 minus pi over 6, that's the same thing as 4 pi over 6. Oh, that's nice. I don't even have to change denominators. Oh, and I can even cancel that down to be 2 pi over 3. So my new period for this is 2 pi over 3. However, and I will zoom up to the top. Sorry if I make you dizzy, but the B is not what your period is. The B is what's in the denominator. It's what I divide 2 pi by. That's what number is out front between like the sine or the cosine and the x. So my B is whatever's in my denominator. So when I come back down here, my new period is 2 pi over 3, but that's not my B. The B is just 3. So whatever's in the denominator is my B. So 3 goes in between sine and x. I did not move up and down any at all, so I have no plus or minus attached to the end. This function can be written as 1/5 sine times 3 x minus pi over 6. Okay, that's sine. Does anyone have any questions? Okay. Let's do cosine then. You might be like, I don't see cosine, that's why I only see sine. I'm going to argue that cosine and sine are just shifted versions of each other. Cosine starts high, its middle point is the lowest point, and then it ends high. If this were to continue on with its wave, it would get all the way up here. And I truly don't even care where this point is, because sine and cosine will have the same period regardless. So actually the hardest step that we did on the last one is already done for us. So I already know that my period is going to be the same. It's still going to be 2 pi over 3. And so then my b is my denominator 3, just like in sine. The period's the exact same thing. I just shifted over. Instead of starting at pi over 6, I started at pi over 3. Oh, and that leads me to my next piece. I did not start at pi over 6 like I did with sine. I had to keep shifting over to get to pi over 3. So I'm going to say this is x minus pi over 3 to show that I went I went right pi over 3. And then I actually left the easiest one for last. My amplitude, it's still the same as what it was before. 1/5 is my A, it's my amplitude. The biggest thing here is if you are writing both sine and cosine functions of one picture you see, their amplitudes are going to be the same, their periods and their B is going to be the same. The only thing that's different is moving it left and right. Only thing that's different. Only difference is C, is your left and right movement. All right, for sake of time and for sake of other problems, I'm not going to do letter B unless I have time at the end. But does anybody have any questions on this one, writing sine and cosine? I feel like there's one like that on your homework. So we will go over homework next class. So if you have questions, let me know on that later. Okay, I know number 3 is like ones on your homework, so I really want to do both of those if possible. Anybody have any questions yet? Okay. Okay, this one is very similar to all of the other ones that we've done so far. The only new change is now I have a plus something or a minus something at the end. Like I mentioned right at the very beginning of this video, and we haven't touched it yet. And again, I'll zoom back up. So sorry if I'm causing you motion sickness. The one thing I added to this part that was at the beginning of your 4.4 notes is that anything that is added or subtracted to the end moves your graph up and down. Again, we've already done this. You did this with quadratics, you did it with absolute values. Like you've done this, we're just now doing it with sine and cosine. It does make the graphing a little bit more difficult, so that's why I wanted to add it last. So let's look at letter A first. Okay, we're good at this. We know that my number out front is my A, it affects my amplitude, so my amplitude is 2. Next to that though, I'm going to write a flip so that I remember that's what the negative does. So the flip is going to flip your sine graph upside down. We know that the 3 affects my period, so we always do 2 pi divided by b, and b this time is 3. And I actually can't simplify that. That's as good as it gets. 2 pi over 3 is my period. So that's the amount of time, the amount of length that I have to get my whole sine graph in. My plus pi over 6, we just did a bunch of examples like that. That means I'm going left pi over 6. The PS, that means period shift. And instead of thinking it as a period shift, you can call it a horizontal shift if that makes you happier. Because you're just moving it left and right. That's just shifting your whole cycle. And then VS means vertical shift. And that is the last number. That's the plus or minus. And in this case, it's a plus. So we're going to go up, and it's +1. So we're going to go up 1 unit. I don't want you to worry about frequency. If we had more time, I'd care about that. We don't, so I don't. Okay, even if you struggle with other parts of graphing, this first part, we should all be like, yes, I got it. I'm good at this. I can do this. Okay, now I'm going to move over to my graph and we're going to start labeling my axes. I'm going to argue that your y-axis is the easiest one to do. What affects your y-axis is your amplitude and our vertical shift. So before we had done a vertical shift, if amplitude was 2, we would know that we're going from +2 down to -2. You guys wouldn't argue with me. You would have already had that labeled. You'd be like, sounds great, moving on. Now I'm doing a vertical shift though, so I need to move those points up 1. So instead of going from 2 to -2, I'm going to move that -2 up 1 to -1, and I'm going to move that 2 up 1 to 3. I'll label them for you. 1, 2. 1, 2, 3. And so if I was doing a normal graph with no vertical changes like we have done, this is where my grid marks would have been at +2 and -2, but we are going to shift them up 1 unit. So now they're at 3 and -1. Anybody have any concerns about that? Okay, I guess I can also be dramatic about that with my my period shifts. So my period is 2 pi over 3. If I had no left or right shifts, I would go from 0 to 2 pi over 3. We'll say this is 1/3 pi. We'll say this is 2/3 pi. So I would go from here to here. Now my scale might be off, so you need to be nice to me if it is off and it looks kind of funny. But if I'm just kind of making this up, it would go from here to here. However, we're not starting at 0, 0. We're going to the left pi over 6. So I need to go to the left pi over 6, negative pi over 6. And so my like boundaries for my period needs to shift over that way too. So I'm going to shift them over here. Instead of being at 2 pi over 3, we're going to be at 2 pi over 3 minus 1/6. So this was kind of the work we were doing on the last problem that I know was probably, or a couple problems ago, whatever, that I know is probably the most confusing and most frustrating. But I like to think about where would we be if there was no shift. Now we're going to move everything left pi over 6. So if I move that left pi over 6, I'm going to minus pi over 6. Got to get like denominators. So I'm going to multiply top and bottom by 2, which gives me 4 pi over 6 minus pi over 6, which is 3 pi over 6. Oh, I can simplify that even more to be just pi over 2. So I'm now at pi over 2. Okay. How do I want to say this next part? What I would probably think to do next is think, okay, well, if 2 pi over, oh, that's not what I wanted. If 2 pi over 3 was like my end point, I drew this point right here because that would have been my middle. That would have been pi over 3. If this was pi over 3, my middle point in my like original graph before I moved it pi over 6, if pi over 3 was my middle point, I need to move that pi over 6 in order to get my new middle point. So that's what I would probably do here. I'd probably do, okay, pi over 3 minus pi over 6, multiply by 2. That gives me 2 pi over 6 minus pi over 6. And now I'm at pi over 6. Now I'm technically, this is where we have to have some kind of understanding of fractions. I technically now have all my points without doing any more math. I am going from negative pi over 6 to pi over 2. With my understanding of fractions, all of these are a pi over 6 unit away from each other. If you don't trust me, let's try it. Pi over 2 minus pi over 3. That's the same thing as 3 pi over 6 minus 2 pi over 6, which is pi over 6. So the distance from pi over 2 to pi over 3 is pi over 6. The distance from pi over 3 to pi over 6 is pi over 6, because I just did pi over 3 minus pi over 6 to get that. The distance from pi over 6 to 0 is pi over 6, because if you minus anything from 0, it's itself. And then to go from 0 to negative pi over 6, that is a distance of pi over 6. So I have all of my pieces and they are evenly marked on my graph. Again, I mentioned this on the last problem, but again, if you're like, she said pi over 6 one too many times and I already stopped listening, put it in normal fractions. Put it in 1/6, negative 1/6, put it in 1/2, kind of see how those numbers relate. Again, I'm going to argue the pre-cal is not the hardest part for you, it's the fraction work. Okay, whatever. We're just going to leave that number there. Okay, now that I have this labeled, we're ready for the easiest part. We're ready to graph my function. I'm ready to graph my sign. Does anybody have any questions before I start graphing my sign? The only hard part about this is now I'm not going through 0. So a lot of you guys, I'd say, okay, where does sign start? And you'd say it starts at 0. You're not wrong, but when I shift up, it doesn't now start at 0. It's going to start 1 unit up. It's going to start at 1. So I've got to put my first point at negative pi over 6, 1. And that's kind of my new like axis line that I'm used to mirroring around. So my first point, my middle point, and my last point are going through that middle line, that 1, because it's the center of my graph now. The second point goes, oh no, the second point doesn't go that high because I have to flip it. So the second point, instead of going up, it goes to the lowest point, and then the fourth point goes to the highest point. If you forgot what sign looks like, that's why we did it up above. It's on our first page. And I drew all of these boundaries, so I was able to keep my sign in the boundaries. I was able to keep it in my period of 2 pi over 3. I was able to keep it in my amplitude of 2, all of that fun stuff. Okay. Again, the hardest part is labeling the x-axis, then you just throw your graph on there. Does anyone have any questions yet? Okay. This is actually the last one we're going to do in 4-4. I am not going to do number 4 because I just don't want to. So letter B is the last example we're doing in 4-4, unless I have extra time and I'll come back. Okay, the one thing I need to do with this before I start identifying amplitude, period, all that fun stuff, is if you go back and look at all of our problems, do you see that the parentheses had the number on the outside, not on the inside? So like the last problem, 3 was on the outside. And the examples we did, we put 3 on the outside. Literally all of the examples up here, my B was on the outside. It wasn't on the inside. Outside, 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 outside. And even when I gave you the example, B was on the outside. So in order to correctly identify B and C, we need to take that 3 outside of my parentheses. In order to take it out, we're just factoring it out. I'm just thinking about, okay, what if I divided everything by 3? Divide that by 3, divide that by 3, and the 3 now goes out front. 3x divided by 3, oh, that's easy, that's just x. And then pi divided by 3, don't overthink it, that's also easy. That's just minus pi over 3. I have to do that though, or else my period will not be right, my horizontal shift will be wrong. There'll be like a lot going on. So I needed to make sure I take that 3 out and set it up this way. And now I can identify all of these period, amplitude, period shift, vertical shift, but not frequency because we're not doing that. Everyone okay with how I took the 3 outside? Okay, just speak up if you don't. Okay, so I see first, I see this 1/2. That deals with my amplitude. So I'm going to come down here. I find A, amplitude is 1/2. There's no negative, so there's no flip. It's all nice and pretty. My B, my 3 affects the period. So I'm going to do 2 pi divided by 3. Okay, cool. We already did that. That's fine. My period shift is affected by moving left or right. And I'm going to move negative pi over 3. I'm moving right pi over 3. It's opposite of what we think. And then last, I already have it highlighted that -2 is the vertical shift, moves it down 2. Okay, so I have this all set up. Again, this should be the easy part. You guys are pretty good at identifying this stuff. Now's the hard work for setting up our graph. Again, y-axis is the easiest one to do. Let's do that one first. The amplitude is 1/2. So that means I go as high as 1/2 and I go as low as -1/2, but I need to move that down 2 units. You can do this however you want. This is my 1/2. That's my 1. That's my -1. That's my -1/2. So here's 2, -2. If I was at +1/2 and going down to -1/2, now I'm going to move it down 2 units. That's 1 unit. This is 2 units. The easiest way I think of it is instead of being centered around 0, it's centered around -2 now. So technically this point is -1.5 or -3/2, I guess, if I'm going to keep pushing the fractions. And then this last point's at -2.5, which is -5/2. And again, you can label your graph however you want. You can make it as big or small as you want. I need it big enough so I can at least see the picture. All right, now I'm doing the x-axis, which again is the harder one. Okay, let's graph what we would normally see. Normally I would be at 0. Ooh, let's use a writing utensil. I'd be at 0 and I would be done at pi/3. Nope, I'd be done, sorry, 2 pi/3. I got a little excited. Let's move it over just a little bit more then. I'd be done at 2 pi/3. And that makes my middle point pi/3. But we are not starting at 0. I'm not starting at 0 to going to 2 pi/3. I'm starting at pi/3. I'm moving right pi/3. And it means that I end a pi/3 after 2 pi/3. I'm adding a pi/3 to that to move it to the right one. Unit, I guess, 1 unit. 2 pi/3 plus pi/3 is 3 pi/3, which is just a normal pi. This one's actually a nice, easy one too, because I already have my halfway point here. But halfway between pi/3 and pi is 2 pi/3. And luckily, we've done enough fractions. I remember on the last problem when we were doing pi/3, halfway between like 0 and pi/3 is pi/6. So the halfway point between all my pi/3s is by adding a pi/6. So this point is not just pi/6. That's not what it is. It's something pi/6. I'm going to add pi/6 to go from pi/3 to get to pi/6. And then same thing here. Probably the easiest thing I think of, instead of adding pi/6 to 2 pi/3, instead of adding it, I'm going to come from the other direction and I'm going to minus it from pi. So I'm going to minus pi/6 to find those points. All right, let me do my little fraction work off to the side. That pi/3 plus pi/6, get like denominators, 2 pi/6 plus pi/6. Oh, which is 3 pi/6. Oh, we already did that. That's silly. I probably could have used my problem above. The middle point between pi/3 and 2 pi/3 is pi/2. It's 1/2 pi. And then if I do pi minus pi/6, pi is the same thing as 6 pi/6 minus pi/6. 6 minus 1 is 5 pi/6. So this point is 5 pi/6. All right, since all this nonsense above is not in my graph, I'm going to leave it there, or else I would erase it so I could kind of see. But now I have my nice, easy points. I have my, block labeled. If you need to kind of extend these lines out so you know that, like, to keep things kind of safe and sound, you can do that, or you can just kind of eyeball it from here. The very last thing I just double check is which graph am I doing? Am I doing sine or am I doing cosine? And we are doing cosine. We remember that cosine, both of its points are the highest points, its middle point's the lowest, and then it hits the middle line. Normally it's 0, but we went down 2 units, so the middle line is -2 as its middle 2 points. Starts high, ends high, middle point is the lowest point, and then it's kind of in between points at pi/2 and 5 pi/6 are that in between line. Make it look nice and pretty and loopy. And that's my graph. Again, the hardest part is the labels right here, but it's important that we work on that. All right, what questions do we have? Anybody? Okay. We're gonna get into 4 or 5. And the most important thing from 4 or 5 is just identifying the new graphs. Again, I could spend months on this, so we are going to do very minimal transformations of the new graphs, but I think it's important that you see and you can recognize a graph of tangent, a graph of cotangent, a graph of secant, and of cosecant. Yes, so we're going to move on to that next. We're good on time. Okay. So we're going to do very minimal of these notes, but again, I think it's important that we see these things. So we're going to do tangent first. Tangent graph, and just like we did before, can I show 2 notabilities at the same time? Anyone smarter than me? The unit circle, is that somewhere? No, I guess it's not labeled unit circle. Okay, I'll just pull it aside. We'll just kind of go switch back and forth. Okay, tangent, just like we did for sine and cosine, I want us to like identify what my tangent is at those quadrant angles. I care about 0, 90, 180, 270, 360. So let me jump over to my unit circle. It's in a different guy. He's over here. Okay, so we remember that tangent is y over x. So tangent is y over x. So I'm thinking about all of these as my y divided by my x. My tangent at 0 radians is going to be 0 divided by 1. So my tangent there is 0. So the very first point I put on my graph is going to be 0. Can I switch to my notes now? Okay. I feel like there should be a way I can do both at the same time, but I guess I'm not smart enough today. Okay. I'll even just draw a little unit circle. You have all yours, but this point's 1, 0. This point's 0, 1, not negative. This is -1, 0, and this is 0, -1. So those are kind of the points I'm referring to, just because I can't have both up at the same time. So tangent at 0 is 0. So I'm going to go put a point at 0, 0. Okay. Let me give myself some labels just so I know where I'm going. We'll call this guy 2 pi. We'll call this pi. We'll call this pi over 2. And we'll call this 3 pi over 2, because I told you those are the ones I care about. At pi over 2, we're going to come up here, pi over 2. My tangent here is going to be 1 over 0. And 1 over 0 is undefined. We can't do that. So I can't have a point there. If you remember from like our reciprocal functions, when we have undefined, we draw a little asymptote. I cannot have a point there. There's no point there. We draw an asymptote. Okay, when I get to my 180, my tangent is 0 over -1, which is also 0. So my point at pi is 0. And then at 3 pi over 2, it's -1 over 0, which is another undefined. Erase some of this nonsense. And then at 2 pi, it's 0 over 1 again, which is still 0. So tangent has zeros at 0, pi, and 2 pi. Oh, that's a great idea, Cam. If I get a stopping point, I will look at that. Okay, so tangent is at 0, pi, and 2 pi. The points that we don't look at, just because I don't need us to spend time on, are the in-between points, but this is what we're going to remember. Tangent is positive as we go from 0 to pi over 2. Tangent is positive in the first quadrant, so the graph, its points are going upwards towards the asymptote. They always approach it, they never touch it. In the second quadrant, though, tangent is negative, so that means all of these points are negative. In the third quadrant, it's positive again, so I'm kind of looping up to the positive. If you look at this middle graph that I just finished, it kind of looks like a cubic function, right? So I think in my head, tangent is like a cubic function and it goes through 0, pi, and 2 pi. And then it repeats again. In the fourth quadrant, it's negative. And then if I were to go around again to the first quadrant, it would be positive again. So tangent looks like a bunch of little cubic functions. Its amplitude, we're going to say 1. It truly doesn't really affect much, but we'll say our amplitude is 1. And actually our period is not 2 pi, because you see even what I've drawn, it starts to repeat itself. Technically, it's just pi. Technically, if I go from 0 to pi, I've done all of the tangents that I need, and everything after that is just repetition, just repeating. It's not really going to affect us too much, but it's kind of interesting to look at. Okay. So that's what tangent looks like. And in the same breath, let's do cotangent because it's very, very similar. However, cotangent is the reverse. It's not x over, or it's not y over x, it's x over y. So wherever I had 0 before, so like where 0 happens, the point, the angle 0, it's not 0 over 1, it's now 1 over 0. And so that's my undefined point now. Where my undefined point was in tangent at pi over 2, because it was 1 over 0, it's now the opposite. It's now 0 over 1. So now it's 0. Basically, we're flipping where the asymptotes and where the zeros go between tangent and cotangent. So let me set my little angles up. 2 pi, pi, pi over 2, 3 pi over 2. Instead of having a 0 at 0, I'm going to have an asymptote here. Instead of having an asymptote at pi over 2, I'll even zoom out so you can see it. Instead of having an asymptote at pi over 2, I'm going to have a 0 here. Instead of having a 0 at pi, I'm going to have an asymptote. And instead of having a asymptote at 3 pi over 2, I'm going to have a 0. And then the last one I'll do is 2 pi. I'll have an asymptote there, not a 0. So I switched which points were zeros and which points were asymptotes. I'm going to use the same logic though to decide how my little like cubic functions lines go through. Between 0 and pi over 2 is the first quadrant, and we know tan is positive there, so its reciprocal cotangent is still positive as well. It's just going to come downwards to this pi over 2. In the second quadrant, it's negative, so it's going to go downwards again. It's going to keep being in the negative part. When I go between pi and 3 pi over 2, that is a positive for the tangent. So it's also positive for cotangent. So that's going to be on the positive side. And then when I go from 3 pi over 2 to 2 pi, that's on the negative side. They look almost identical. They're just flip-flopped. They're reciprocals. They're flipped. My amplitude is the exact same. The period is the exact same. It only takes pi units to get my entire cosine, and then it's just like copy, paste, copy, paste. So I remember these look very cubic in nature. I'll say look cubic. They are not cubic. They just look like cubic functions. So really the only thing I need you to know from this is like knowing what tangent and cotangent look like and telling the difference between them. So if I showed you 2 graphs, I could say, okay, which one's tangent, which one's cotangent? Anybody have any questions yet? Okay. All right, let's do secant and cosecant. And I actually think these are super interesting because they go off of the graphs we just were learning. So we know secant is the reciprocal of cosine. That's the same thing as 1 over cosine. I'm actually going to graph cosine, and then from that graph, we will build a secant graph. So I'll do it in like this light pink. I'll build cosine in this light pink, and then we'll graph secant in green from it. Well, let me actually label my axes first. Okay. So we've been doing cosine for days. I can do a normal cosine graph, easy. I label all of my important parts, pi over 2, pi, 3 pi over 2, and 2 pi. I go as high as 1. I go as low as -1. You can even draw your little boundaries if that is helpful. I know it's helpful to me, so I hope someone else finds it helpful. If not, that's okay. And then in this light pink, I'm going to draw cosine. We know it starts and ends low, or high, excuse me, Its middle point's low, the other 2 points go through 0, go through the middle of the graph. Okay. Since it's just like cosine, its amplitude is still the same. Its amplitude is 1, its period is still 2 pi. So tan and cotan were the only ones that were funny where they had pi as a period. Okay, so now I'm thinking secant is 1 over cosine. So we're looking at these important points and we're going to draw points on our secant graph from that. So the first one at 0, cosine is 1. So 1 over 1 is still 1. So this point shares the same as cosine. If that point shares the same, I also know 2 pi shares the same. Okay. At pi over 2, my point is 0. So that's like 1 over 0. Well, we just learned 1 over 0 is an asymptote. Sorry, I got my A words mixed up. Asymptote. So if pi over 2 is 1 over 0, that's an asymptote, and so is 3 pi over 2. And then the last point at pi, it's -1, and 1 over -1 is still -1. Okay, cool. They share the same point. Okay. What happens here is I'm going to do the reciprocal of it. So I'm doing 1 over all of these. So instead of my points getting closer and closer to 0, they're going to get bigger and bigger and bigger. What I'm essentially drawing from these points that are 1 and -1 are, they look like parabolas. They look like quadratic functions because they go to 1 and -1, and then they get closer and closer to the asymptotes. Closer and closer to the asymptote. Go from -1 closer and closer to the asymptote. Same thing over here, closer and closer to the asymptote. If it makes you happy, you can finish that one and go extend it out, because like I would have another asymptote coming up over here, or you can kind of leave it unfinished like that. So secant looks like a bunch of quadratics. It looks like a quadratic or a parabola, but it starts at 0, 1. We start up at 1. It shares the exact same point that we had before. This is going to be super similar for cosecant because it's sine. We're going to have little quadratics here. The only difference is it's going to start at a different point. Anybody, any questions before I go look at cosecant? Okay. Cosecant, its amplitude is 1 as well. Its period is still 2 pi. This time it's 1 over sine. So we're going to graph our sine graph first. I go 0, pi over, or 2 pi, excuse me, pi over 2. That might not be great, but that's okay. I go as high as 1, go as low as -1, and draw my little boundary. Just like we did on the last one, I'm going to draw sine first in this like light pink. You might draw it lightly with a pencil. We know sine goes through 0 at the beginning, the middle, and the end. And then a normal sign, a positive sign, starts up and then it ends low. Starts up, ends low. Like something like that. Okay, by the same logic we were doing on the last problem, anytime I have a 0, so like where I'm going to start, it will be 1 over sine or 1 over 0. That's an asymptote. So every time I'm touching the x-axis right now, it's an asymptote. Asymptote at 0, asymptote at pi, asymptote at 2 pi. My other important points are +1 and -1. And like we saw over there, if I do 1 divided by 1, it's still that point. If I do 1 divided by -1, it's still that point. We already know it looks quadratic, so we go from +1 and we approach the asymptotes on both sides. Approach asymptote, approach asymptote. Same thing at -1. We are at -1 and we approach the asymptotes, approach the asymptotes. So the difference between secant and cosecant is cosecant, its first like quadratic point starts at pi over 2, comma 1. If that's not helpful to you, you don't have to know that. I thought that was helpful. And then I wrote it out and I was like, that might not be helpful. You maybe think instead it starts with an asymptote. That might be your thought process. Whatever little cute trick helps you remember the difference between those. Again, the biggest thing I'm just trying to teach right now is the difference between these pieces. I want us to show us all the graphs and I wanted to know the difference between them. Okay. Okay. Anybody, any questions? Okay, the very last thing we're going to do is we're going to skip all of these transformations. I will not ask you to do that on your test. I want to do number 2 and number 3. Number 2 is a unit circle type because it says no calc. The second one says solve with a calculator. So we're going to kind of do these two together. These are asking for our angles, x, x, x. We want to find the angles. Okay. Let's do the unit circle one first. I think that's the harder one. So I got secant. Secant we know, and we just reviewed, was 1 over cos. And so 1 over cos, I can think of that as being 2. If I want to think of that as a reciprocal, my cosine would be the reciprocal of 2, which is just 1/2. So I'm looking for where my cosine is 1/2. My 1/2 is positive. So we got to remember all students take calculus. Cosine is positive in 1 and 4. So I'm looking in quadrants 1 and 4, where cosine is 1/2. And that is at 60. Or it asks us to give radian. So I'll do 60 and pi over 3. That's the corresponding radian. And in the 4th quadrant, the 60-degree angle is 300. And that's 5 pi over 3. So we've done this in like a little different of a capacity. We're just kind of looking at cotangents, tangents, and secants instead of just sines and cosines this time. Okay. Cotangent is 1 over tan. Or I think almost an easier way of thinking about this is x over y. So we want our x over y to equal -√3. I'm going to argue that we've done enough of these that I already know what x is and I already know what y is. In order to get √3 by itself, no denominator, I need my √3 over 2 to be on top and I needed my 1/2 to be on bottom. Because when I multiply by the reciprocal, the 2's are going to cancel, which leaves me just the √3. So again, by pattern, by repetition, I know that I'm looking for an angle whose x is √3 over 2 and whose y is 1/2. I do also know I'm in a negative cotangent. So I have to think, okay, where is cotangent negative? I know it's positive in 1 and 3. So that means it's negative in the other 2. It's negative in 2 and 4. And so where my x is √3 over 2 and my y is 1/2 in quadrants 2 and 4, that is at 150, which is 5 pi over 6. And it's at 330, which is 11 pi over 6. Whoa. Anybody questions yet? We're kind of combining all these skills. Any questions? All right, the last unit circle before we get our calculator out. Tan of x equals 1. Again, I'm going to argue we've done this enough times. Tan is y over x. And we know the only way for something divided by something to equal 1 is when it's the same number divided by itself. And the only time that happens is √2 over 2 divided by √2 over 2. If you don't know that, I'm just going to help you out. You should just start knowing that. And that point where √2 over 2 and √2 over 2 is my angle, it's at a 45-degree angle. Now, I'm actually going to use 45 here, but I might need to think for a second, okay, is this positive or negative? It is positive, and tan is positive in 1 and 3. So I'm looking at the 45-degree angles in quad 1 and 3. And in quadrant 1, my 45 is just 45. That's cool. Pi over 4. And in quadrant 3, I'm at 225, I think. Yeah, 225, which is 5 pi over 4. Okay. Any questions yet? Okay, at least want to do A and B. If I have to stop at that point, that's okay. Now you need your calculator out. I'm pulling my calculator up. This one says we're solving with the calculator. So that's how I know I'm okay to use my calculator. And it's also telling me that I'm doing tan of X equals 1.75. My directions say X is less, or 0 is less than or equal to X, which is less than or equal to 2 pi. That to me says my mode is radians. So for your quiz the other day, I said, just go ahead, put your calculator in degrees. You only need degrees. I'm telling you right now, we're going to switch it to radians because this right here says use radians. So I'm going to say enter. Okay, my mode is radians, switch it out. In order to find X, we did this with word problems. In order to find your angle, we have to do my inverse tangent. X is going to equal tan to the negative first or second tan of 1.75. I'm in radians, so my calculator knows I'm talking to it in radians. So I just do second tan 1.75. So X equals 1.05. If it makes you happy, you can write radians behind it because it doesn't have a pi, so that might be confusing to you. But you don't have to. 1.05 is my answer. The only reason B and C look a little bit different, or going to feel a little bit different, is they're cosecant and secant. So I can't just do, second cosecant in my calculator, second secant. I have to think of this in terms of sine and cosine. So we know secant is the same thing as, it's a reciprocal of sine. So I'm going to think of this as 1 over sine equals 7/3. And in order to use my sine button, it can't be 1 over sine. It needs to be normal sine. So I'm going to flip my fractions, flip my 1 over sine, flip my 7/3. So sine of X equals 3/7. Oh, and now I can do my inverse sine, sine to the -1 of 3/7. Second sine 3 divided by 7. X equals 0.44. And again, you can write radians at the end if that makes you happy. Any questions yet? I'm gonna squeeze this last one in just because I hope another example is helpful for you. So secant we know is the same thing as 1 over cosine. And you don't have to write this intermediate step if you don't want to. You can just immediately flip it to cosine of X equals -2/3. And then we do our inverse cosine, second cos to the -1, whatever you want to call it. And I throw that in my calculator. Second cos -2 divided by 3. And I get X equals 2.3. Whew, okay. We did a lot today. Anybody who's with me have any questions? Okay.
How did you know to put your calculator into radians?
Awesome question, Cam. You see right here where it says 0 is less than or equal to X, which is less than or equal to 2 pi.
Yeah.
2 pi is in radians. So that tells me my answer, my X, needs to also be in radians.
Okay.
Awesome question. Anybody else? Okay, I'm gonna stop my record, but thank you guys all so much for being here.